In this video, we'll go over the basics of configuring Slurm and how to use it effectively for competition purposes. Slurm is a job scheduler. This means that you can use it to schedule tasks to run on your cluster when the resources needed are available. In the real world, job schedulers are usually used as an interface for other users to request compute resources from a larger cluster shared with others. In our case, Slurm can be used to ensure that no two tasks are competing for resources, for example, trying to run two benchmarks at the same time. We can also use Slurm to have various scripts queued up to run without needing to monitor each script for its completion, which is particularly useful if you want to relax while your cluster works through all your scripted tasks. Teams who make full use of scripting will find Slurm extremely useful for automating installation and testing. To make sure that your Munge is correctly set up across your cluster, each node needs to have identical key files. You can test if Munge is working correctly by first encrypting information, then piping that encrypted message over to a different node where it gets decrypted. If everything is working correctly, it should print a success message like this one. Next, we need to create a configuration file for Slurm. This file will usually be found at etc slurm and be named slurm.conf. This file contains all the information we need Slurm to know about our cluster for it to work. The cluster name can be anything. In your case, you will most likely want it to be your team name. Next, the Slurm controller host. In my case, I put it as thr0, which is the name of my head node. This node will manage all the jobs and the communication between compute nodes. Next, we have MPI default. In my case, I have selected PMix version 4. This is the communication API which Slurm will use to communicate with your MPI implementation by default. Run the command pmix_info to get the particular version of pmix installed on your system. In my case, that is major version 4, hence why I used pmix_v4. Going back into our configuration file and scrolling down a bit, you will see Slurm controller port 6817 and Slurm D port 6818. This port over here is the port which our controller needs open, while this port over here is the port which our compute nodes need open. You'll also notice some directory and files listed randomly in the configuration file. Make sure that these directories are created and that Slurm has access to these directories. After that is the srun port range, which is commented out here. If you have a very strict firewall, you may want to set a specific range for which Slurm can communicate over, and then open these ports in your firewall. Do note that you still need these ports over here, 6818 and 6817, to be opened as well. Skipping all the way to the bottom, we can now enter the details for all of our compute nodes. It always needs to start with the node name, which can either be a single node or it can be a list of nodes, either using a comma separated list or a list specifying a range using square brackets as I have done here. Since I have compute nodes thr1 and thr2, I use square brackets to indicate this. Next, you'll see that I have sockets of which I have 8. Cores per socket is 1 and threads per core is also 1. You can get this information from the command lscpu, as you can see over here. threads per core, cores per socket, and sockets, which matches what we have put in the file. Afterwards, you need to group your nodes into partitions. At least one partition needs to be made. You can think of this partition as a grouping of nodes. For your partition name, it can be whatever you decide to label that particular partition. Since we only have one partition, we will select all the nodes to be in that partition, and we will set this partition as our default. Once the configuration is complete, we can start the Slurm controller and compute node services. Type in the command sinfo will list all of our compute nodes at idle. If you see the state over here saying down or drain, then you will need to either restart your Slurm services on those compute nodes, or you will need to change this state using sudo iscontrol update, and then selecting those particular nodes and changing the state to idle. Now with everything working, let's go through an example of using Slurm. Let's say you wanted to figure out what dimensions work best for HPCG. This benchmark requires that the timed portion runs for at least 30 minutes for it to be valid, meaning that every time you test it, that's another 30 minutes spent unable to progress further on other tasks which need constant input. Instead of sitting around for a few hours just to occasionally change the same three numbers over and over, we can create a script and schedule it through Slurm to run late at night when no one is signed onto the system. So here I have a script which will edit the config for HPCG's dimensions and then run the benchmark. At the top of the script, we're able to set Slurm specific settings such as how many ranks per node, how many nodes to use, what time to start the job at, what file to store the output of the script in, and what name to give the job. There are other settings as well, and you can check that out on their website page for sbatch. After these settings, I record the starting timestamp for which the script started and then go into a for loop. I then run HPCG with these three options, editing the HPCG configuration each time. You'll see here that I'm using srun instead of mpirun. This command is just the job launcher native to Slurm, which will talk with Slurm to allocate resources to each rank as needed. After that, it calculates how long the entire script was running for and prints it. We'll be able to see this input in the output file that was specified over here. Once we are satisfied with our script, we can go out and we can schedule it using sbatch and our script name. You are able to overwrite the Slurm specific options that are set inside the script, such as, for example, the number of nodes you want to use. Do note that this will overwrite the values inside, meaning that your script may not use values that you were expecting it to use. And so if we just click enter, you will see that our job is now submitted at 11. And if we type in squeue, you will see that our job is waiting here to begin because it is not yet the time that we specified inside the script. Thank you.